So last time we started this matrix multiplication problem, and the focus here is to minimize the number of multiplications we do when we multiply matrices. Okay, so I kind of reviewed matrix multiplication last time. So if you want to multiply two matrices, so let us quickly review it one more time and then we'll continue. So if you want to multiply two matrices, say A is a m row n column matrix, B is n rows p columns matrix. The rule is the number of columns in the first matrix should match with the number of rows in the second matrix. So after you multiply, the resulting matrix is going to be of dimension the number of rows from the first matrix and the number of columns from the second matrix. So like here you have 3 by 4 matrix and 4 by 2 matrix. So the number of columns in the first matrix matches with the number of rows in the second matrix. So then only you can multiply two matrices. So the resulting product matrix is going to be of dimension the number of rows from the first matrix and the number of columns from the second matrix. So in this case is going to be a 3 by 2 matrix, which means 3 rows and 2 columns. Now we have not really multiplied anything, we can just still find the dimensions of the product matrix. So that's what we're going to do in the entire topic here. But if you just for curiosity, how to get any specific cell, so let's say I want to get this cell 1 comma 1, which is row 1 column 1. So multiply row 1 in the first matrix with column 1 in the second matrix. So it is 3 times 1 plus 4 times 4 plus 1 times 3 plus 2 times 5. So you add up all these things, it's 32. So that is the value of this cell. Now if you want to get this cell, which is row 1 column 2, multiply row 1 in the first matrix with column 2 in the second matrix, like what we just did. So 3 times 2 plus 4 times 5 plus 1 times 2 plus 2 times 1, row 2 column 1. Sorry, row 1 column 2, row 1 in the first matrix, column 2 in the second matrix. So if you want to get this cell, which is row 3 column 2, so multiply row 3 in the first matrix with column 2 in the second matrix, and so on. So now what we are going to focus is the number of multiplications we did to fill up each cell. So to fill up this cell, we do what? 4 multiplications. Why? We multiply the first row 1 with column 1. So you do like 3 times 1 plus 4 times 4 and so on. So the number of multiplications we do to compute this cell is 4 multiplications. Similarly, for each cell, we do 4 multiplications to compute that cell value. Now where that 4 comes from, it comes from the common element dimension. So this is 4 columns here, 4 rows here, and they have to match. That's why in order for us to do this multiplication, the number of rows in the first matrix should match with, the number of columns in the first matrix should match with the number of rows in the second matrix. Then only you can multiply these two matrices. So that 4 multiplications come from the common dimension. So that means if you have to do 4 multiplications for each cell, how many cells are there? 3 times 2, 6 cells. So the total number of multiplications we do is 3 times 2 times 4, or which is 3 times 4 times 2. So that is the total number of multiplications we do for this example. So that is nothing but the 3 is the row dimension in the first matrix, then the common dimension 4 times the number of columns in the second matrix. So in general, if you want to multiply two matrices of dimension m by n and n by p, the number of multiplications we do is m times the common dimension n times this p. That's the number of multiplications we do to multiply two matrices of m by n and n by p. So that's something important you have to remember. Okay, so let us continue. So let us see a motivating example of why we need to look at this problem. Okay, of minimizing the number of multiplications, what's called a chain of matrix multiplication. It's called the matrix multiplication chain. Now Let us take an example. So let us say you want to multiply these three matrices A1, A2 and A3. So the dimensions of each matrix is given here. Now since there are three matrices, there are two possible ways we could multiply as a brute force approach. If you want to explore the different options of multiplying these three matrices, you could multiply A2 and A3 first, and then whatever the result of this multiplication of A2 and A3, then multiply A1 with that result of A2 and A3 multiplication, and then you get the final answer, right? And another way to do that is multiply A1 and A2 first, and whatever the result of that product matrix, multiply that with A3 and you will get a resulting product matrix. So both should give you the same final product and matrix. The answers should be the same. But what is going to be different is the number of multiplications we need to do in each option could be different, and our goal is to pick the option that will minimize the number of multiplications. Okay, so let us see. So this is going to be the dimension in this example: 3 by 4, 4 by 5, 5 by 2. So if we were to multiply A2 and A3 first, the number of multiplications we'll do to multiply A2 and A3 is going to be 4 times a common dimension 5 times this 2. So that's going to be 40 multiplications to get this product matrix of A2 and A3. And what's going to be the dimension of this product matrix of A2 and A3? The common dimension goes away. It is going to be a 4 by 2 matrix, right? So when you multiply these two matrices, 4 by 5 and 5 by 2, the product matrix is going to be 4 rows, 2 columns matrix. So now we are going to multiply A1 with that product matrix. So A1 is a 3 by 4 matrix. The product is a 4 by 2. So if you multiply them, the number of multiplications you encounter here is going to be 3 times a common dimension 4 times this 2. So it's going to be 24 multiplications to multiply these two matrices. So the total multiplication is going to be 40 multiplications to multiply A2 and A3 and get this result, the intermediate result, product matrix. Then 24 multiplications to multiply A1 with that intermediate product. So totally we encounter 40 plus 24, 64 multiplications. So that is if you do A2 and A3 first. Now what if you multiply A1, A2 first? So you have what, 3 times a common dimension 4 times 5, that is 60 multiplications to get this intermediate product of A1 and A2. And then what's the dimension of this intermediate product? It's going to be like 3 by 5 matrix. Then multiply that result with A3. The number of multiplications you do here is going to be 3 times 5 times 2, that's 30 multiplications. So 60 plus 30 is 90 multiplications. So you see, you encounter different multiplications overall with these two options. So obviously you want to minimize the number of multiplications. So you would prefer to multiply A2 and A3 first and then multiply A1 with that result. And as I said before, the final result of the matrix is going to be the same. It's going to be what? A 3 by 2 matrix. This is also going to be a 3 by 2 matrix with all the entries. Everything is going to be the same. So we are not focusing on that in this problem. We are focusing on minimizing the total number of multiplications. Okay. So what we are going to do is, in general, if you're given a chain of matrices, A1, A2, A3 up to AN, each of dimension. So this is the notation we'll follow. A1 is going to be P0 times P1 and A2 is P1 times P2. Okay, let me stop for a minute and convert this video so I can start a new video on this. 1 second.